Welcome everyone for the second live interaction session. I think this will be the last live interaction session for this course, LA Tools. Thanks for joining this course and thanks for registering for the exams. I hope everybody's preparing. Um, the last week will be next week. I hope you learned something from this course, and we try to keep this course as a basic intro so that everybody can understand even without much mathematical knowledge. Um, I think prepare the content which we talked about, like SPM, kappa scores, some of the basic functions of correlation. I think that is enough for the course. I think visiting all the assignment questions would cover at least 80% of the questions in the end like exams. So thanks for joining. And in this session, instead of we go directly on the questions posted in the Google form and discussion forum, we want to cover an important topic which is recently being most used in the LA community. It's called ENA. I think one of our TA, I think Amit, you would have been interacting with him in the discussion forum. Mostly Amit will be responding most of your questions for last week 5 to week 8. Amit is the one who's in charge of that. So Amit will be talking about the ENA in detail. ENA although started like 15 years ago, 15 more than that, I think Devi Shafna was started long back. Due to their the workshops and their meetings, it has been very popular now. In fact, in last couple of conferences in learning analytics community and the EDM community, more than half a paper had ENA or ONA in their analysis. So since it is so important, what we thought we'll have some session about 20-minute session on what is ENA, how it is created. We already know what is process mining. It is kind of similar but different visualization, and we will stop with the very basics here and we'll suggest a couple of papers to read. So if you're interested, go ahead and read those papers. That would help you to analyze your own data and try something. So Amit will share. So what we will do, we'll start the entire screen. Entire screen, yes. Yeah.
Thank you, sir. So for today's session, we'll talk about the epistemic network analysis. So we'll give the background of ENA. So basically this ENA is designed by the learning scientist. They have fundamental assumption that learning is situated and social and happens in a group or communities that have a specific culture as they develop ways of thinking and doing. You can see in the image, there are learners who are interacting with each other and they are building upon some knowledge. Okay. So each community or group has a discourse, which is a language with other social practices like behavior, values, ways of thinking, the clothes they share, the food they eat, customs, and perspectives. So within a specific group. So based upon that, this discourse happen, and a person and the other person, they can build their different concepts.
So the idea is that in a group of 5 students or 3 students, they might be talking about they might be talking about idea, where discourse is the verbal discussions. Though we are discussing the ideas and, I'm opposing ideas, accepting it, asking for more help, all those things kind of discussions. So that's a behavior we call it as.
Yes. So the general definition or explanation of epistemic network analysis is it is a method for identifying and quantifying the connections among elements in coded data and representing them in a dynamic network model. So few minutes back when sir said that the discourse is happening and the behavior is coming, so it is changing with respect to the time. So that is why the dynamic network models. So which data types we can use to create a ENA? So we can use qualitative data as well as quantitative data. The qualitative data like discourse, interview data, the learners' interactions, the survey data that we conduct, Also the reflections in the classroom settings, the transcripts we can use through the interview or video analysis. And then we can have the social media data, maybe a chat in Facebook chat or even in YouTube chat. You can check how the conversations are building. Also in quantitative data, you can use log files or eye tracking data and different physiological sensors as well. The data from the physiological
I
sensors.
think we can take some examples in previous slide.
Yeah.
So consider there is a group of five people are interacting. So suppose me and Hamid are starting the discussion. We talked about a topic. Say the topic is on ENA. Slowly we move to SPM. So we're saying, oh, SPM as ENA is connected. So new topic is emerging. So the discussion is between two. The topic can be the points, the topic initially, within the topic, we both are talking, then the new topic emerged, then we're talking. If a third person comes into this group, that person becomes new node. I think how the connection between me and Amit talking on this ENA, we move to SPM, but the other person coming in, my connection established and Amit's connection established. It's a dynamic process. The whole like whole interaction is for 5-10 minutes. It happens in a dynamic. So that's called this is dynamic. So it can be an interview data. So when you're interviewing one-on-one, the ideas they are talking can be changing over a period. Learners interaction data, we saw that students reading, watching video, discussion forum. That data, how it changes, like a process model, how are they significant data, in which action more significant, what are the relation between each actions, something like that. So that's the idea. I think to give the overview, the data is sequentially captured. We want to represent the sequential data in a nice graph. Yeah,
right. Thank you, sir. So let's take an example. So there is one student who is performing actions like in our process mining data set. We have seen about like reading, writing, then video watching, then going to the forum. So consider here as the actions are A, B, C, D. So this particular student is performing the actions like A, B, C, D, A, B, C, D, A, B, C, D, and A, B, C, D. So here this A, B, C, D becomes the nodes, and we can check the links like over the period they have building it up. So A to B to C to D. Again, so what are the weights here? So if you plot this completely, so it is equally distributed. So that is why the link weight of A to B and A to C is kind of equal, as well as B to C to D to C and B to C. So here you can see all these nodes are making connections with each other, and this particular red dot is consider it as a center of gravity of this particular graph. So just because all these links are equally distributed, so this is at the center point.
Okay, I think here the simple correction is that this is just a representative purpose. We are not actually computing the A to B, A to C link, because we would see that A to C there's never the link happened, or the B to D never the link happened. But just to represent that in a sequence, we are going to compute what are the four actions. Four actions become the four nodes. The link between these actions, A to B happens, B to C happens, C to happens, that is the links.
Yes.
I think we'll go next slide. We'll see how is that.
Yes. So again, so same student has maybe a different sequence. So here, if you see this, the occurrence of B, D, and C is happening continuously. So suppose this is B, C, D, again B, C, B, or again if you look B, C, D. So this is continuously happening with respect to A. So the weight of this three links are more than weight of this AB and AC link. In this case, because this weight is increased, the center of gravity is moved to this particular point. In next slides, we will look at what is this red dot and what are all these nodes. So particularly here, nodes are the codes, the links are the connection or co-occurrences, the weights are the frequency of the occurrences, and this red dot is a centroid. So this was one example. Now I will go in deeper of what are the parts of the ENA. So there are typically three major parts of ENA: units, conversation, and codes. So what are units? You can refer units as a people, concept, groups, or anything whose network of connections you want ENA to model. So for example, students, their actions, or their typical groups. So maybe students from first years, maybe students from third years. So you can group them. So that becomes your units. Now the conversations are the collections of the lines within which ENA models the connection between the concepts. So for example, let's say students, how they are like having a discourses in 5 days. So those days become the conversation, or what are the different activities they perform in those days, or in that particular session. So that will become the conversation. Now, what are the codes? The codes are the concept whose patterns of association you want to model. So suppose we had this read, write, like, so that can become the codes for your ENA. Sir, anything to add?
No, I think good.
So if we see here, we have, this is just for the example. So here there are multiple red dots and multiple blue dots. So this each dot is one particular student. So red, and that is why there is this, if you can look at this, this is a square, and there is one more square inside, a solid square, and this is like a dotted square. So in this case, this is one student, and the mean of all these red students is here, and this is a confidence interval. Similar to the blue ones, so this is one blue student, this is one blue student, and this will be the mean of all these blue students with respect, again, it has their confidence interval. Okay. So here, so nodes are codes, continuing with the previous slides, then link, and centroid is this. So this is centroid, and mean is this square.
So I think we should be wondering that how each dot, like the red dot students and blue also students, why each dot is represented in different locations. I think as Hamid mentioned previously, that based on your connections, your actions, the centroid of your network become the one red dot. But where should I put the red dot here? So what is, which we're not gonna talk in detail, is what happens is that suppose I have a data of say 10 dimension. What ENA does it reduces to 2 dimension using some of the dimensionalization technique. It can be the singular value decomposition technique. It's this kind of something related to PCA. What it reduces to 2 dimension, when it reduces to 2 dimensions, some of the features, some of the dimension features will be closely associated to 1 dimension, some will be in other dimension. So that is why SVD1 will be like mostly representing all the dimensions. Because we're reducing the dimension to a 2 dimension, when you do the plotting x and y axis, x axis will be the dimension x2, I in W2, the rate will be based on which actions you perform. If you're doing more actions related to the features corresponding to the dimension 1, the red dot will be placed near the, that x or y.
The dimension. So in
That's the
next,
idea.
so what are those? So look at this figure. Sir was talking about this SVD1 and SVD2. So if this particular person performs more actions from this, so it will be closer on SVD1. Similarly, if this particular student or learner perform more actions related to design learning, so it is plotted here. So we are not going in the details of the mathematics behind it. This is just kind of overview of ENA bit 2. So going back here, the parts when we say the nodes are codes. So suppose, so this technical constraints, designing, reasoning, data, performance parameter, collaboration. So these are the nodes in this particular ENA. The links, that is connection or co-occurrences between these two nodes. So technical constraints and designing, reasoning. So this is link, and this is because of the co-occurrences of these two codes. Then wets, if you can see, this particular line has a like a thicker, this is thicker line, and this line is a thinner line. So the co-occurrences of these two codes are more than the co-occurrences of these two nodes. And as I talked, the centroids, which is the dot of each student, and the mean. So you can see it here.
Okay, I think we have a couple of queries about this. The thickness of the lines represent the weights of the connection. Yes, if you see this thickness here in this particular code, a deep design reasoning and technical constraints is mostly thickness and the darker also. As in the process mining, also same thing we explained it that, which means these two actions co-occur mostly, like either deep reasoning and constraints occur together. So it occurs mostly. So the AB or BA, it occurred together mostly. That's why the lines are thicker. And why the red dot is second part changed in the previous slide? It is changed because in the example, we just want to show you example that if the more number of actions happen in the two actions, A and B and A, B and C, the line, the center would move there. Okay. It says that where's the most significant action occurs, the center will be that place. So just to show the how this dots are representing, if you're not getting that point, why the red is moved, it's okay. Instead, here the idea is that ENA creates for each students, there's a network. When I'm trying to combine with the multiple students, it tries to create a average network. Then we want to show how this network can be used for comparison. How this network has been created, we will talk about. Yeah.
So this is individual network. So this particular graph you can see is about the first game. The similar graph will be there for the second game. And so ENA has one more thing known as a subtracted network. It basically subtracts the links or the link weights from the one cohort and the other cohort. So here the cohorts are this first game and the second game. So this is the subtracted network of first game minus second game.
So we'll go. So the red dots are the first games.
Yes.
The blue dots are second games. Consider red dots are the red dots are kind of first year students. Blue dots are second year students. We could create a graph for individual students separately. When you want to compare, we compare it. Then if you see in the previous graph, the connection, the design reasoning is very thick, but it might be thick in both groups. So the difference is very minuscule. That's why the line become thin. So when I say subtraction network, we subtract from group one, that is a first game cohort, to the group two cohort. The connection become very thin. The thing. So what appears is that whichever the difference is high in the group one become a red, wherever the difference, like most connection in the group B become a blue one. You see that connections of red ones. These connections are appeared more in the group one compared to group two. Similarly, the connection between design reasoning to performance parameters appeared more in the group two compared to group one. So it's a good tool to visualize how the sequence of actions happened, how dynamically how it happened changed, and is there any difference among this? That is a tool for it, I think.
Yes. So ENA interpretations, just like this kind of superficial thing, just guidelines how to interpret ENA. So look for the thick lines and look for what is there or what that is where the meaningful co-occurrence is happening, the thick lines. The thinner lines are, these are also meaningful, but the co-occurrence is less. Whatever sir speak in like last 2 minutes, then you have to tell the story. So whatever the learner is doing, the collaboration while thinking more about the technical constraint in this particular thing, then or the learner doesn't give more emphasis on reasoning and designing while doing collaboration. So you can tell the story from this lens, whatever your data is saying. So in this particular example, there was technical constraints. So it was talking about that. So you can connect it to your data and create a nice story around this visualization. I will directly move to the demo of ENA web tool. So this is a link, or you can scan this and then it will take you. So before that, I will show you a data set. So this is a data set. This is open source data set you can use. This is from Rescue Shell game. So you can scan this and you can go to this data set. And what is happening in this data, I will tell you in the brief. So this RS data, that is rescue shell data, consists of a discourse from a rescue shell game. It is an online learning simulation where students work as interns at a fictitious company to design a robotic legs for mechanical exoskeleton in simulated work environment. Throughout the internship, the student communicate with their project teams and mentors via online chat. So this particular data is having a discourse in online chat. So let's go to uh, this epistemic network. Yeah, so this is front page of ENA web tool. Here you can log in. So I might use this login as a Gmail. Oh, I don't have the access to it. So maybe I will move.
I got another. Your phone.
Yeah. Harit, my phone. Okay, so this is how I will actually go in the new project so that
So it just when you start a project, start a new project, then you enter the project name and you have create a project. It will ask you for uploading content.
yes. So first of all, I'll speak about this UI you can see. So here in this the black strip, you can see the sets. This is the place where you can upload your data set in CSV file or Excel sheet. Then the second one is model. It will give you units, conversation, and codes. So you can manually enter your units or conversation from the Excel sheet. Then this is the plot tools where you can change the settings in the ENA. And then there is a stats. We'll talk about this plot tools and stats once we upload the data set. So suppose I'll go in the sets, then go in the folder, select new tool or new set. Before that, I have to
Download the data.
yeah.
Control. Yeah. That only is lines. Back.
Okay, so here you can see this RS documentation, RS data processed, and RS processed data. So this will be the data set with one hot coding, and this will explain what are all the columns of this data set.
Username.
Yes. So here in this data, you can see there is the username, then condition usernames are units you can select, then condition first game and second game. So act as a first game. The students who have used the simulation for the second time, or if they have used already other simulation and then they are coming to this SQL data, then they are tagged as a second game. So similarly, this text is a chat between the students. Then there are some confidence check. So what are their confidence while checking this simulation or while doing this simulation? So so these three columns represent that. And depending upon their scores they got. So if it is below than the 5, then they get C level pre. And if they get more than 5, then they have tagged as a C change. Also, there are activity numbers. So there are 14 activities, and it is mentioned with respect to the student. So student 1, activity 1, and then something. So student 2, activity 2, then something, or student 1, activity 2, and then something. So you can look at the data. Then there is a timestamp of whatever they have done for first game, second game, for multiple activities.
But the important thing is, if you don't need to worry about, you need to have all the data in your analysis. All you need is a student ID, as we talk about in this course, student ID. What's that? What's the person involved in it? Like suppose two students are interacting in the discourse, or their action is continuously happening. The action and timestamp. Even timestamp is not compulsory. Which group they are belongs to? They are first year, second year, third year, the cohort, action, and the ID. That's all you need.
Yeah. So here there is a group name. So few students has a group name as electric. Few students has a group name as a hydraulic. So you will be able to see in the ENA tool. Then game half, game day data you can look, and then there are codes. So this data, technical constraints, performance. So in if they are using, or if in their Discord they are talking about the data, then that particular line is coded as 1 for data. If not, then 0. Similar for a technical constraint. If their chat consists of a technical constraint, if they are mentioning it, then they will code it as a 1. If not, then 0. So similar for performance parameters, then client and consultant request. If clients or consultant are requesting for any changes, then they have coded as a 1. If not, then 0. Similar for design reasoning and the collaborations. So you in your data set, you can have multiple codes with respect to your data set, and you can code it 1 or 0 if it is present in that particular chat, or if that action is performed. So you will code it as 1. If not, then 0.
Okay. So for example, the discussion happens. The concepts coming in the discussion are these things: data, technical constraint, performance, and the client interaction. All those are things we want to code. This is code we mean as a code. Suppose your actions kind of reading, writing. Suppose you have a set of actions. Suppose your action is say 5 actions: read, write, watch video, discussion forum, and highlight. The 5 actions. There will be 5 dimensions. Whenever the action happens, you put 1, otherwise 0. So it's called one-hot encoding, which we talked about in the week 2 on data preprocessing. We convert the actions into one-hot encodings. This one-hot encoding is what used in the ENA to create the graph.
So let's move to ENA.
Did you download it? I think.
Yes.
To go back. Go back. Get the same. Could minimize this. CSV or Excel?
CSV or Excel sheet,
fine.
both works. So here, go here.
Moves to top in the bottom.
Yes. Okay. So click on new set and choose a file. So here you get 2 options: either manually create the model or use tutorial. As you are new to this ENA tool, use tutorial, and then click on the create button. It will give you step-by-step tutorial what to select and how to select. So suppose it will take you to the units at very first. So the description of units is given. And so for this data set, I'm considering username. So all the participants as units, as well as I want to group them with respect to maybe conditions. So first game and second game. So it becomes my unit. Okay. So all the students and the first game. So this is step 1. Go to second step, where you want to have the conversation. So consider the conversation in which the lines in which you want to see the network is building. So for example, again, I can choose the conditions, that is first game, second game. Also, uh, I can look for the username as well, or else maybe their group names. So which different groups have performed the activity. Also the activities. So activity number 1, 2, 3, 4, whatever the number of activities are there. So here in this particular data set, I have conditions, then group name and the activity. Then go to next. Here you can select the moving stanza. Uh, so by default it is 4. You can select multiple moving stanza, maybe 5, 6. It depends on your data. If your data has the discourse of on an average of around 7 to 8 lines, then use the moving stanza at 8. If it is more than that, then go for that particular thing. So look in the data and then decide the moving stanza. But 4 is by default it is given.
Okay, I think we'll talk what is moving stanza is. If you think that the meaningful action occurs within the 3 sequence of actions, our meaningful conversation would happen in, say, 5 interactions between. So I talk one thing, I will talk the 5 set of conversations. There's a meaningful action because I want to check in the moving window of 5 instances. Can I plot a graph? Then I plot it like a sliding window. I plot it like every 5 actions. Then I put it all together. Then I normalize it by divided by 4 because it is 5. So the idea is that sometimes you can have a moving stanza as a n number of actions. If I have 20 action sequences, moving stanza can be all 20. It can also create one. Or I want to say 2 or 3 or 4. You could vary it. Suppose if 3 students are interacting in a group, I say that keep 4 because for at least 4 or 5 conversations needed to make in an average, to one complete conversation to happen. That's my assumption. So you can vary it and check it out. That's the key thing. Yeah.
So here the codes, so like sir mentioned and I have already talked. So here I'm going to consider this data, technical, performance, clients, design, reasoning, and collaboration. So all the codes for which you have done 1-0 coding, you can use it here. And then
So the actions.
basically
Actions or constructs or ideas, all these things can become codes. Yeah.
Yes. And then comparison. So either I can go for game half or something. So it will consider all the things that we have considered earlier.
Or the electric or hydraulic.
Hmm.
You want to compare 2 groups. Which group you want to compare? Is it a cohort 1 or cohort 2 or electric versus thing? Our first game versus second game. So you can use a choice.
Yes. And then
You're choosing the group name. Yeah.
yes. So we can look what is happening. So after that, it will give you a review. The last step is review. You can review what are your units, conversation, codes, comparison, stanza window, everything. If you figure out that the codes are missing, or I have added one extra line which is not meant to be in the final graph, then you can go back and then deselect or select. And then finish. So once you click on the finish, it will take some time, few seconds to plot the graph. Okay, so such errors can come. You can see, so suppose here units are group name, username, or condition. So there are multiple. So because group name is
used in the condition
used,
also. In condition also.
So maybe what I can do, I can deselect or select something.
I think group name cannot be the because group name we are comparing. We could remove the group name and put the condition and
Condition and the username I can put.
Yeah. Conditions. Top condition the top option. Yeah, condition.
Okay, so
And yeah, let's see how it is. It is actually creating that growth. Yeah,
yeah.
how it is that.
So you can move this and check how to do it. So this is one particular student for all the networks. Okay. I think there is something is missing. One code is. So I want to check the conditions and the students in it.
It is the username and condition.
Yes, username and conditions. Correct. Just a second, I'll go back to the values, comparison values.
It is selecting a new name. Check the
Maybe.
game type.
Hmm.
I think instead we could select the group name. Yeah, okay. That'll be comparing to.
Yes. Maybe username is not. Okay. Okay. So you have to play around for some time and then check. So this is first game. All the conditions are mentioned here, and then the second game. So also conversation, these are the conversation and these are the codes. So all the codes are selected. Maybe I have to change something.
I think it involves both. You see, the first game involves 1, 2, 3, 4, 5 type of the game thing. Also the group name. It involves all three of them. We keep one of them, not
Yeah, so
the groups.
maybe we can remove
Yeah,
group
the
name.
groups that would it's only combine the first game and second game with those same the people in it. Yeah. That's because we kept three parameter together. We're not able to compare. Now we are comparing the game, first game or second game, and within the game, who are the participants? Who are the participants? We're just comparing two students for the codes, two groups. If you are, if you're comparing, what is that? The electric hydraulic, then you'll be getting five groups. So let's go with the binary always. That's easier.
So this will plot. So this red ones are students who have performed for first game. This is for the second game. So you have to click on this. So this is mean of all the students. If you don't, or if you want to see what this particular student is doing, so if you click on this or if you hover on it, then you can look at the ENA for that particular student. If you want to compare this student with this student, so click on this. It will give you the comparison plot. So suppose this primary plot is first game, this Adrian, and this is first game of Peter, because we have selected these two people. If you want to remove and compare this particular student with someone else, so maybe one person from the blue, then this is second game from Luke. So this is for individual students, and for the group of student, you can select the mean. So here the mean of first game and the mean of second game. So this is the central diagram is a comparison plot of first game versus the second game. In the right hand side, you will see the first game, the average of first game and the average of second game, the ENA for this both. Then you can go into the plot tools. Here you can change the minimum age weight. So if you want to remove a link which has a very less weight, so you can increase it. As you increase it, those lines will be gone. So consider it as a saturation point. So below that, it will remove, and above the weight, it will consider. Also, you can change the width of the links so that you are able to see it properly, how this is connected. So you can use this too. Also, you can explore what are this x-axis, y-axis, how to show them. Do you want to show this percentage in your visualization or not? Do you want this variance to be explained or not? So you can explore this. The last part is stats. If you want to do the statistical analysis on this group 1 and group 2, so you can do the t-test. So suppose here first game, select first game, then ultimately the second thing will come, and then select which one you want. So for this we are going to do non-parametric, and after that you will get to see the p-value, standard p-value here. So this particular graph represents uh, so they are significantly different because the p-value is below than 0.05. So that is why the star. And along the x-axis and along the y-axis, it is greater than 0.005. So that is why no significant difference. Okay. And similarly, you can do this goodness of fate, variance, and theory and method. You can explore it.
So we did non-parametric test because we don't know whether this forms a normal distribution or not. If you're in doubt, just use a non-parametric. If you want to do parametric test, you should do the pre-calculation and check it out. So a couple of questions on this. What happens if stanza size is minimum maximum? Minimum can be 1, but 1 makes no sense because there's no connection between the things. So we keep it minimum 2. That is not a problem. If it is a maximum, can be the total number of sequences. I think you could play around and there's not actually any weight difference. But the idea is that the things changes dynamically. If you put all together, it's just a simple probability distribution map. You know, the transition matrix between these actions. What happens if changes dynamically? Is there any more nuanced details we get it? That is why we keep window sizes, stanza sizes 3, 4, 5. And also, if you wanted to say that I want to create a graph for 3 different instances, first 10 minutes, second 10 minutes, third 10 minutes, you could play around with this. So that's up to you. Changing the weight will remove the edge connection, whether it is leads to loss of information. It is up to you, the researcher's decision, whether you want to consider the weight, you want to keep all those lines and make some sense, or you want to, no, I want to key important, anything above 0.5 is what important for me. It's the same as the process mining we discussed. The idea is that this is a good visualization tool. You have to take this co-occurring actions and do your own analysis and to write something meaningful. So we will go back to the slides. I think we already got some time, right? So demo. So what we did, we get 2 papers here. This paper in 2021 Bowman, they talk about all the mathematical foundations behind ENA. Please read it to understand all the mathematics behind this, why this particular graph is created. So what is SVD means, what is meaning of this located in a particular quadrant. Or also we sharing the paper, it is not recent, but there's a paper from another paper from Mohammad Saka's team. The paper is about review of things happened in ENA. Also, what is the drawback? I think in 2022, Mohammad Saka wrote it. Followed by Mohammad Saka actually published a book on LA methods, which we shared in the course earlier, you know. That's also interesting book to read. And in the book, he is suggesting a couple of more visualization techniques to look at it. So we request you to check this review paper, and it would get papers happened. But what really happened is after this 2022, there will be at least 200 papers published in ENA. In 2023, 2024, I think everywhere it is ENA. So even in this year, in the AI and EDM conference, it's all about ENA and ONA. So we would recommend you to check what is ENA, ONA, how the people are looking at it. That's more interesting. This content will be added as part of the course, but this content will not be part of the exam for this year. So yeah, from the next year it will be added. So we'll move on to the questions from the Google form. I think there's not many questions. One question is about reflection activity with NLP. We are not sure whether we didn't talk about reflection activity in NLP in our course, but if it is any thing about the students reflecting on a given topic, students reflecting on their own learning, I think that is possible in NLP, and with help of Gen A, people now are doing actually good. It's asked the three teams in one of our app design course are working on the reflection in the classroom. For example, a teacher creates the content, students reads the content, they reflect on the content. Those reflections teacher can come and see, then they will able to give feedback. The kind of collecting the reflection content and giving feedback has been done using Gen AI. That is the one thing is happening. So reflection is a key part in learning. We didn't talk about it in NLP because we didn't go in detail, but reflection also can be related to NLP to summarize, to generalize it. This is what we understand reflection. If you mean reflection is different, we don't know what exactly how it is connected. But we say reflection, student reflects on their own learning. It's very important, self-reflection. The major question as discussed in the discussion forum is box plot. But before that, one other question we saw the data editing and data reduction. In the pre-processing week, we said that data editing is the data imputation. Suppose in a whole graph, only few places there some data is missing. Instead of removing that whole row or column, you could say, can I impute it using the mean or median or adjacent value or something like that. But if you see the particular column, if 30% data is missing in one particular column or one particular row, we could remove the whole column or the row. That becomes a data reduction. So data editing is not removing data, instead imputing data like with mean, median, average, or the previous and last value. Data reduction is such that it occurs at random, but it occurs to all the students. This particular column is missing in almost 50% of students we collected data. Remove that column. That's the idea. Regarding box plot discussion, I think this has been done. I think today also one question we saw that in box plot. I think let me clear how box plot idea is that. Box plot represents 4 quartiles, right? The number of data point in each quartile should be equal. That is the whole idea become box plot. So let's have some number, say some 9 numbers I'm giving. Also, I'll give another example with the 10 numbers. We'll go with that. So let's have some 10 numbers. We will go here, say 25. I'm putting everything in the 1, 2, 3, 4, 5, 6, 7, 8. Okay. There are 9 numbers in it. So of course the median will be 38. So median is the center line. Now I will consider median to split it. No. If I consider median, the number become 32. Suppose if I consider median, the IQR 1 will be 32. There will be 2 numbers before and 1 number in the second quartile. That is not correct. So we should not consider median. So this is number. Since it is an even number, 4 numbers, we should identify the average. Average is 31. Here the average will be 64 and 70. The 6 or 67 will be the average. So if I make the box plot, 31, 60, this is the 38, the median. This is quarter 1, maybe this is a bit lengthier. You see the minimum value is 25. So here we have 2 values, 25 and 30. Here we have 2 values, 32 and 36. This is 38 is involved, it's a median. Here we'll have 62 and 64, 70 and 72. The idea is that each quartile is equal. That is what. So let me go with another example. Maybe I will I'll come back. Another example, I will do it here. Sorry for the thing. So same set of data. So 26, 28, 32, 60, 60 is. So 36, 38, 42, 45, 1, 2, 3, 4, 5, 6, 7, 4, 5, 6, 7, 8. Now there are 8 data. So what I would have median is this 4th data. 37 is the median. Now I will take anything below this. Median is not included. There are 4 data now. That will become a 28 and 32 will be 30. And this 4 data will become 42 and 45, so 43.5. If I wear a box plot, 37, although this data does not exist. In this year, we have 26 and 28, 30 is the value. 32 and 36 here, 38 and 42 here, 45 and 47 here. This is the idea. So the box plot, the whole purpose is to can I create the equal quartiles all the way? That's the whole idea we want to do. So the question is, can I include median? Here the median is 37. I'm not including median in the even numbers. If it is odd numbers, never include the median. Okay. I hope this is clear. These are the two questions we saw. I think yeah, I don't think any other questions came today in the live interactions. So thanks for participating, and we will convert this last 10 minutes as a live interaction video. The remaining video will edit some points where we are corrections. We'll edit technical issues. We'll correct those edits. We'll upload some 30 minutes video for the ENA. Somebody wants to watch it, but it'll be part of the course from next offering. And for the exam, most of the questions are from the assignments, similar to assignments, 80 to 90% of questions. Very few questions will be a bit open-ended. That's all. So thanks for this course, and thanks for joining, and all the best for exams. Thank you. So I'll end the Zoom meeting. Okay, thanks. So what we want